Welcome everyone. Today we're looking at lesson 3.4, parallel lines and transversals. We're going to specifically look at angle measure. So our goal is to find out the measure of angles formed by when transversals cut parallel lines. Got some keywords as the same ones we've been dealing with for the last few days. So here is a tennis court. If you know anything about tennis, there's something particular about the sideline here and the baseline. Hopefully you know from what you've seen that that is actually 90 degrees. Okay. Now what do you know about this baseline right here and the service line? Hopefully you're saying in your head, well, they're parallel. So, and also, you should probably know that this service line and this sideline right here make a 90-degree angle. Does that make sense? Okay, so now, what kind of angles are those? How do they relate to each other? Well, since they are in the same location, then they are corresponding angles. Okay, same location, corresponding angles. And look, the service line and the baseline are parallel, and those angles happen to be exactly the same. So that leads us to this first postulate. It's called the corresponding angles postulate. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. Okay, so if you look here, remember corresponding angles, there are always going to be four pairs of, always, four pairs. So they are color-coded in this diagram. Angle 2 and angle 6, those are both in the upper right-hand corner. So right here for symbols, it says if J is parallel to K, then the following are true. So angle 2 would be congruent to angle 6. How about angle 1? If I say angle 1 is congruent to, you're going to say angle 5. Then lower left, angle 3 and angle 7. And then lower right, those black ones, those are 4 and 8. So angle 4 is congruent to angle 8. Okay, and there is also a short form. A lot of times you're going to have to explain your reasoning. So when you say two angles are congruent to each other and you have this situation going on, you will say, you could say something like because angle 2 is congruent to angle 6 because parallel lines cut by a transversal. Actually, that's not what I want to write. What I want to write is simply this: parallel lines, therefore corresponding angles are congruent. That's shorthand for this postulate. Parallel lines, therefore, that's what the three little dots in a circle or in a triangle mean. Therefore, corresponding angles are congruent. Okay? All right, I hope that makes sense. All right, so visualize it. This is just a picture. Look for an F. Okay, when you're looking for corresponding angles, they're always going to make that F if you want to trace them. So up, over, and then over here, and you get that little F shape. So here's an example. We're not going to do all of these just for time's sake. So A, find the measure of angle 6 right here. Well, if you look at it, it's always a good idea to kind of highlight what you're dealing with. So I'm dealing with this angle right here in the upper right corner and this angle right here in the upper right corner. So the measure up in the top said 60 degrees. I hope I didn't overdo it too much. Said 60 degrees. So the measure of angle 6 equals 60 degrees. How about letter B then? What's the measure of angle 5 going to be? They're in the same location, top left, so the measure of angle 5 is going to be 135 degrees. If you do letter C, what should the measure of angle 2 be? Should be 90. All right, here's another theorem. There are actually four. There's one theorem for each of our four angle pairs. So these are for alternate interior angles theorem. If two parallel lines are cut by a transversal, then alternate interior angles are also congruent. Okay. So in symbols, if J is parallel to K, then the following are true. So look at this here. Here's angle 3. Would you say that's acute or obtuse? How about angle 6? Look at that one. So if you look at 3 and 6, those are both obtuse angles. and those are congruent to each other. So angle 3 is going to be congruent to angle 6, and angle 4 is going to be congruent to angle 5. Okay, so those are alternate interior angles. So we have parallel lines, therefore alternate interior angles are congruent. That's an A. Alternate interior angles are congruent. Okay. All right, so here's another example. So you got to figure out, first you have to know where angle PQR is. Okay, this is the angle in question, PQR. So identify that. All right, so PQR is right here, PQR, so that's this angle. Over here, PQR, so that's this angle. And then PQR, so that's this angle right here. All right, so if you look at the angles that I colored in and the numbers that are given as far as angle measures, those are all alternate interior angles. So since here's 35 degrees and this one, alternate interior angle with it that's the alternate interior angle with it, so it's also 35 degrees. So the measure of angle PQR equals 35 degrees for that first one. Number 2 then, the measure of angle PQR is going to be 120. Make sure you put the degree symbol on there, please. That's a notation issue, notation standard. And then lastly, the measure of PQR is going to be 70 degrees. Okay, I hope those make sense. And we'll do something with that later in class too. Third theorem, alternate exterior angles theorem. So if two parallel lines are cut by a transversal, alternate exterior angles are going to be congruent. So then we look at those, they're color-coded for you. The measure, or angle 1 is going to be congruent to angle 8, and angle 2 is going to be congruent to angle 7. Oh, the short form of that, parallel lines, therefore alternate exterior, so alt ext angles are congruent. Shorthand. So this one kind of uses a combination. If you look at the 75 degrees, you're supposed to figure out the measure of angle 1 and the measure of angle 2. 75 degrees is an exterior angle. Okay, so if you look at the 1 and the 2, angle 2 would be the alternate exterior angle to the 75. So does it make sense that the measure of angle 2 has to be 75 degrees? Okay, then as you look at 1 and 2, 1 and 2 together make a linear pair. Okay, a linear pair is supplementary. Supplementary means what? They add to 180. Sum is 180. So to get the measure of angle 1, I'm just going to subtract 180 minus 75. So the measure of angle 1 is going to be 105 degrees. So there's your angle 1 and your angle 2. Okay. So we're bringing back some old terms there, linear pair. So this is a checkpoint. I suppose I would suggest you pause the video and do these. You're supposed to decide whether or not these angles are congruent or not congruent. Okay, so pause now and try them yourself. All right, so let's see how you did. Angle 1 and angle 8, so those are alternate exterior angles, so those would be congruent. How about 3 and 4? 3 and 4 right here, those actually make a linear pair. Those fit none of our descriptions, so these are going to be not congruent. Okay. 4 and 2, those also make a linear pair right here, so those are also going to be not congruent. You could also find out all of the angle measures since you know that 120 and then figure out congruent or not congruent. Last theorem, absolute last one. This one's a little bit different. So same side interior angles, same side interior, look at those. Okay, you have angle 3 right here and angle 5. 3 is acute. Would you say 5 is acute or obtuse? That is obtuse. If one's acute and one's obtuse, can they be congruent? No. So if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Supplementary. Okay, so if J is parallel to K, then the following is true. The measure of angle 3 plus the measure of angle 5 equals 180 degrees. The measure of angle 4 plus the measure of angle 6 also equals 180 degrees. Okay, and we do have a short form for this as well. It would be parallel lines, therefore, same side interior angles are supplementary. And you could use SUPP. That would work for my class. Okay. I like shorthand. It's nice for explanations. Okay, so that visualize it to the right here. I actually have a bigger picture next. So visualize it. Look for angles inside a C shape to find same side interior angles. That's just kind of a reminder. Remember, same side means you're always on the same side of the transversal. And interior, you're in between the two lines. So you're looking at these two angles in between. So you'd be looking at this one right here and this one right here. Those are your same side interior. Remember, one of those typically is going to be obtuse, and the other one would be acute. And if you come over here to the other side, now we're looking at the left, so that obtuse and acute just, actually those didn't switch because the picture changed. So there's acute, and here's obtuse again. Okay. All right, so find the measures of the same side interior angles. So they're supplementary. So the measure of angle 5, I'm going to do 180 minus 80. And so the measure of angle 5 is going to be 100 degrees. Letter B, I'm going to do the same thing. These are same side interior. First, you have to decide what pair it is. Then you can decide if they're congruent or supplementary. So this will be 180 minus 130, which is 50. So the measure of angle 6 equals 50 degrees. Okay? All right, so here we're putting in some algebra, but first we need to know what the angle pair is. First, ID the angle pair. Okay, so these right here, I'm looking at this angle, and I'm looking at this angle. Hopefully you're telling yourself that those are corresponding. And so now I decide what about their angle measures. So corresponding angles, if they were parallel, and these are, we have the parallel markings right there, then those are going to be congruent. So we will simply set these equal to each other and solve for x. So 125 equals x plus 15. And now just do your algebra. Subtract, and that's 110 equals x. Okay, you don't have to have the degree symbol on the 110 because it's the entire angle with the degree symbol. Okay, just depends on your teacher. All right, so number 6 and 7, same thing. First, decide what your angle pairs are. So I'm looking at this 120 and then this x plus 35. Those are alternate interior angles, and the theorem said that alternate interior angles were congruent as long as we had parallel lines, which we do. So again, 120 equals x plus 35. Then solve. Okay. So subtract your 35. Subtract your 35. So x is going to be, was that 85 degrees? Or 85? Okay. All right, so then over here, I'm looking at this 78 in number 7, and then this x minus 2. Those are on the same side of my transversal. Here's my transversal T, and these are parallel lines. So these are same side interior angles, and same side interior angles are not congruent. Those are supplementary. So now that I see that they're supplementary, I'm going to do 78 plus x minus 2 equals 180. Okay. Combine like terms. So 78 and the minus 2 gives you 76 Now subtract your 76, and we get x equals 104.